Now here's something a little bit different. Calculate the angle, correct to the nearest degree, between two straight lines given in Cartesian form. Well, to calculate the angle between two things, I'm going to need to use the dot product. So the first thing I have to do is get each of these lines, turn them into parametric form, from which I can read off the direction vectors for the lines. So let's try L1 first. We said each of these bits equal to lambda, the parameter. X plus 3 over 5 equals lambda, and 3 minus y on 2 equals lambda. Rearrange those. X plus 3 equals 5 lambda. X is negative 3 plus 5 lambda. And this one says 3 take y is 2 lambda. Carefully with the negative sign, leave it where it is for one step. Negative y is negative 3 plus 2 lambda. So y must be 3 minus 2 lambda. So that's the parametric form for this line, from which we can read off this is the fixed point on the line and this is the direction of the line. Therefore, the direction of L1 is given by a vector we'll call A, which is x-coordinate 5i, y-coordinate minus 2j. Let's do the same for line 2. I'll just leave this down a moment so we can copy this down. Each of these has to be set equal to the parameter. Now, I could still use lambda for my parameter, but it's better not to because it's a different line and won't necessarily have the same simultaneous values as this one. So to avoid confusion, I'm going to use the next Greek letter. This is letter L, the next letter is M, and the Greek letter is mu. Sorry, Greek alphabet is mu. So we're going to set each of these equal to a parameter mu. X minus 4 over negative 7 equals mu. And y plus 3 over 5 equals mu. Rearrange each of these into parametric form. X take 4 is negative 7 mu. X is 4 minus 7 mu. Y plus 3 equals 5 mu. Y is negative 3 plus 5 mu. So, in the same way, the direction of L2 is given by a vector we'll call B. This is the fixed point, this is the direction. Negative 7i, that's the x-coordinate, and the y-coordinate, plus 5j. So, for me to get the angle between these two lines, I want the angle between these two vectors. To get the angle between these two vectors, I'm going to use the dot product. How's that work? Just to remind you, cos of the angle between them, let me draw you a quick little diagram so you know what I'm talking about. A and B, and this is the angle between them. Cos theta is A dot B over the length of A times the length of B. We're confident enough just to put those in. A dot B, we're going to do it component-wise. 5 times negative 7 plus negative 2 times 5 divided by the length of A. The length of A is 5 squared plus 2 squared, and the length of B is 7 squared plus 5 squared. Well, that's negative 45 divided by, this one is 25 plus 4 is 29, that's a prime number. And this one is 49 plus 25. 50 plus 25 would be 75, so this must be 74. Oops, I've gone off the screen, just noticed. Sorry about that. So, negative 45. This is 25 plus 4 is 29. This is 49 plus 25, which is 74. This one's not prime. Does it have square factors? We can find out easily like this. We go menu, number, 3, factor, and put in 74. It's 2 times 37, so there's no square factors, and therefore we can't simplify any further. We could, however, put these two numbers together. If I times that by 29, I get 2146. So that is negative 45 on square root of 2146. Actually, I didn't need to worry about that, did I? Because I'm just going to get the inverse cosine. Theta is cos to the minus 1 of negative 45 on square root of 2146. And that is trig cos 45 over square root of 2146, 166.3 degrees. Oh, it says to the nearest degree. So I can actually go 166 degrees. Whoa, I made a mess on my screen. 166 degrees. 166 degrees. Now, the thing is, it asks for the angle between straight lines. Now, your textbook doesn't do this. I assume because they're saying, well, we've given them to you in parametric form, so find me the angle along those vectors. But by convention, I mean, these are actually lines. So the fact that I've actually found an obtuse angle, the angle between the lines could be this one or it could be this one. So you're just as it writes to say, actually, conventionally, I would give the smaller angle, the angle in the first quadrant. So if you prefer, instead of 166, you can have 180 minus 166, which is 14.